Hello and welcome to another session in physics. In this session we'll be looking at the topic electromagnetic spectrum, the detection and uses. Well, let's start with the definition and concept of electromagnetic waves. The definition and concept of electromagnetic waves. Now, electromagnetic waves are waves that have been produced. They have been produced as a result of electromagnetic vibrations. One thing about electromagnetic waves is that they have the electrical origin and the ability to travel in vacuum. Yes, they have the ability to travel in vacuum. They can travel through space. So, electromagnetic waves are regarded and treated as a combination of traveling electric and magnetic forces which vary in value, and they are directed at right angles to each other and to the direction of travel. So in other words, we call them transverse waves. Let me point out that we have two kinds of mechanical waves. We have two kinds of mechanical waves. We have the first one, which is transverse waves, and we have the second one, which is longitudinal waves. Transverse waves are waves that where the direction of travel and the speed of travel or the path of travel is quite different from each other. They are at right angles to each other. Notice here it says that the electric and magnetic forces vary in value and are directed at right angles to each other and to the direction of travel. So the magnitude of the wave and the direction in which the wave is traveling to, they are not in the same plane. They are at right angles to each other, and that's what makes them transverse waves. On the other hand, longitudinal waves are waves where both the magnitude of the wave and the direction of travel are in the same plane. They are in the same plane. Either they are parallel to each other or they are in the same direction. So they are longitudinal. But for electromagnetic waves where magnetic forces and electric forces combine together, they are called transverse waves because they travel parallel to each other. Now, we want to talk about electromagnetic waves, what they look like, or examples of them, and what they basically consist of. We have many kinds of electromagnetic waves, the first being radio waves. Radio waves are known to have a wavelength of 10 raised to power minus 3 meters up to 1000 meters. When we say 10 raised to power minus 3, we mean 1 over 1000 or 0.001. So from 0.001 meters to 1000 meters. That is for radio waves. And then for infrared waves, they have average wavelengths of 10 raised to power minus 6 wavelengths. 10 raised to power minus 6 means 1 over 1 million or 0.12345 meters. That's what they have as their wavelength. And then we have the visible spectrum. The visible spectrum is known as light waves. Light waves are known to have wavelengths of about 7 times 10 raised to power minus 7 meters for red rays. Red rays are known to have the longest wavelengths in the visible spectrum. And then another kind of electromagnetic waves we have is the ultraviolet rays. The ultraviolet rays. Ultraviolet rays have wavelengths of about 10 raised to power minus 8. Very small wavelengths. And then X-rays have incredibly short wavelength of about 10 raised to power minus 10 meters. And then gamma rays have the shortest wavelength of 10 raised to power minus 11 meters. So these are different types of electromagnetic waves which come under radiations, and they are very, very important. Now let's look at them critically one after the other. Let's start with radio waves. As you can see from the previous slide, you would notice that radio waves have the longest wavelengths. Radio waves are emitted from what we call transmitters, and they carry radio signals to radio sets. The shortest radio waves are the ones we call microwaves. Microwaves are used in radar. and they are used in heating. Hence, that is the reason why they are used in cooking, because they have the capacity to produce heat and get food done. And then we have infrared waves. Infrared waves are found just beyond the red end of the visible spectrum. They are present in the radiation from the sun or from the filament of an electric lamp. We have so many manufacturing industries that use infrared lamps to dry paints on painted items. Yes, they use infrared lamps to get some paints dry when many items have been painted, for instance painting of cars. Infrared waves are also used in the treatment of muscular problems. Now let's talk about the visible spectrum of light waves. The visible spectrum is made up of the Roy wave, like we talked about. The Roy wave, red stands for R stands for red, O stands for orange, Y stands for yellow, G stands for green, B is for blue, I is for indigo, and V is for violet. You would notice that these are all colors of the rainbow. Now, when these rays combine with each other, they form what we call a white light. When these rays combine, they form a white light. In the visible spectrum, red rays are known to have the longest wavelengths, while the violet rays have the shortest wavelengths. You can see that they are at the extreme rare ends of the visible spectrum. Yes, red is at the beginning and it is the least deviated, hence it has the longest wavelength, while violet is at the end of the spectrum and it is the most deviated, so it has the shortest wavelength. Actually, the main source of light is the sun. Alright, let's talk about ultraviolet rays. Ultraviolet rays are located just beyond the violet end of the visible spectrum. It is found just beyond the violet end of the visible spectrum. Ultraviolet rays can be produced by what we call quartz or mercury filaments, or even by the sun from solar energy. That is the reason why some materials have the capacity to fluoresce. When we say fluoresce, we mean glow. So ultraviolet rays can cause certain materials to glow. Now let's talk about X-rays. Of course, you must have heard about X-rays, especially if you have had somebody go to the hospital to try to take a picture of the internal structure of their body. Possibly somebody suffered from a fracture and they need to know exactly the position of the bone, or if it is actually healing the way it should. X-rays come into the picture. The importance of X-rays, and I would say X-rays is one of the most important radiations that we will ever have in the world. The importance of X-rays cannot be overemphasized. X-rays are produced when fast-moving electrons strike a metal target, and this metal target that they've struck tends to reduce their velocity. So X-rays are used in hospitals basically to destroy malignant growth in the body, to destroy malignant cells in the body, such as cancerous cells, and they can be used to produce X-ray photographs, like I mentioned before, which can be used to locate broken bones. But too much of everything is bad, and for that reason, much of X-ray in the body is harmful and can lead to sterility, a situation where a man cannot be able to get his wife pregnant. The man becomes sterile or infertile, and it can also cause adverse changes in the blood. The person could begin to suffer from sicknesses such as leukemia, or the person could begin to suffer from excess bleeding. Also, in industries, X-rays are used to locate cracks in metal castings and flows in pipes, especially in the exploration of crude oil. Another importance of X-ray is that it ionizes gas and it has a penetrating effect such that they pass through opaque substances that are opaque to white light. They pass through them. They are diffracted by crystals and they are not affected by either magnetic or electric fields. So that makes them very, very useful. Now, gamma rays are emitted by radioactive substances such as cobalt-60, uranium, and polonium. out of X-rays, beta rays, and alpha rays, and gamma rays, note that gamma is the one that has the shortest wavelength, and because of its short wavelength, it has high penetrating power. So like X-rays, gamma rays have the capacity to ionize gases and darken photographic plates. Now, when it comes to detectors, we have detectors of various radiations in the electromagnetic spectrum. If we want to detect gamma rays, we use the Geiger-Müller tube. X-rays, we use photographic films. For ultraviolet rays, we use photographic films too, and fluorescent substances, or substances that glow. For visible rays, we have the eye. The eye can detect visible rays. We have photographic films. We have photoelectric cells. For infrared rays, we have our skin, we have the thermometer, the phototransistor, photographic film. And for radio waves, we have our radio set, our television set, and we have aerials that are able to detect some of these waves. Now, what are some usefulness or uses of radiation? Of course, everything that has an advantage also has a disadvantage, but let's focus on the importance of some of these rays in the world of humanity. A knowledge of infrared rays has been useful in helping to develop infrared telescopes, infrared signaling lamps, which are useful to soldiers fighting in darkness. That is the first one. The second one is that with the aid of photographic films, which are sensitive to infrared, it is actually possible to take clear photographs through mist and haze. When we talk about mist, we mean a situation caused by fog and dew, where we can't see clearly, but with the aid of photographic films sensitive to infrared, it's actually possible to take pictures under such difficult circumstances or conditions. In hospitals, X-rays are useful to inspect broken bones, and in industry, they can inspect metal castings, and in science, we use them to study the crystal structure of matter. Gamma rays are used to kill cancerous cells in patients' body, as well as bacteria in food and in hospital equipment. The fifth is that a knowledge of ultraviolet rays is used in developing ultraviolet lamps, and these lamps are very useful in conducting experiments on photoelectric effects. Radio waves, finally, are very important for effective communication and transmission, especially in our radio sets, our television sets, or when walkie-talkie is involved in transmissions between military agencies. And that's it for today. Thank you so very much for joining us in this lesson. To refresh your memory on what we've just discussed, please take the test that will appear on your screen.